Good morning again, grade 8. So for today, we are going to be talking about a new lesson, and the lesson is entitled Energy. You can find this on chapter 2, pages 47 to 53 of your textbook. Okay, let's start. The specific objective for this lesson is this. At the end of this, you should be able to identify and explain the factors that affect potential and kinetic energy. Okay, so again, identify and explain the factors that affect potential and kinetic energy. And before this, of course, or before the discussion on energy, I gave you homework last time. Remember last Monday during the video lesson that I left for you. So you are supposed to answer word storm on page 47. So if you have your books with you, please turn to page 47. If not, please pause this video and get your book so that we can check. Okay? So let's check. Let's start with the one that's across. Number 3, the answer should be electric. Number 6 should be heat. And number 7, chemical. Okay. And then for the words that are going down, number 1, we have nuclear. Number 2, kinetic. Number 4, potential. And number 5, radiant. Okay, so if you look at your answers to the crossword puzzle, these are actually many different forms of energy. Okay, so let's move. Okay, so let me ask you this first now before I continue, and then of course you can pause the video to think of the answer for this. So, what enables you to do the things you enjoy doing and help you do work? If you answered energy to this question, then you are absolutely correct. No, thumbs up to you. All right, moving on. So let's now talk more about what energy is. And if you don't mind, I'll be turning off my camera from this point on. All right, so energy. What is energy? So physics or science defines energy as the ability to do work. Okay, so that's why without energy, that means you can't do any work. Okay, so as you can see from this image, this GIF, no energy means no work can be done. So if you look at the fuel meter, these people who are running out of fuel. That fuel for humans is what's known as energy. Okay. Also, energy has many forms, as we have seen from the crossword puzzle that you have answered as your homework. And you can see on screen, these are just two of the many different forms of energy. Okay. We have here chemical energy, the energy that we get from batteries. And this is like a diagram of a power plant. So that's how we get electricity in our home. So electrical energy. All right. So our focus for this lesson will just be on the two major forms of energy, and these are kinetic energy and potential energy. Okay. Let's now look at the first one, potential energy, or you can just shorten it to PE, potential energy PE. So what is potential energy? Potential energy is stored energy, okay? It's stored energy possessed by a body. So in other words, it's energy that's not yet being used, no, but it has the potential to provide energy, hence the word or the term potential energy. You can also think of potential energy as energy that's waiting or energy in waiting. Okay, so remember that potential energy is the stored energy possessed by a body. And then you can also think of potential energy as energy due to a body's position or elevation. So when we say elevation, this is from a certain height, or in Filipino, taas. Okay? So the higher the elevation, the greater would be the PE, or potential energy. Potential energy, just like energy itself, has different forms, now many different forms. But for this lesson, we will focus on just one, and that is the gravitational potential energy, or GPE. Also, we have a formula because this is physics. We always have formulas to use because, again, math is a language of physics. So the gravitational potential energy is just equal to the mass times the gravitational constant, or just G times the height. Okay, and take note, G is a constant value. It's always equivalent to 9.8 meters per second squared. All right, so that is potential energy. Later on, we will be solving some word problems regarding potential energy. Okay, let's move to the next major classification, which is kinetic energy, or KE. So what is kinetic energy? The energy possessed by a moving body, or energy in motion, is what is known as kinetic energy. So if for potential energy, it's stored energy, or energy that's waiting, meaning it's the energy possessed by objects that are not in motion, or bodies that are not in motion. Okay. Kinetic energy, on the other hand, is the energy possessed by anything that's moving. That's why you can just say kinetic energy is energy in motion. All right, so I've already mentioned this. All moving bodies possess kinetic energy. Okay, so if you're running, walking, exercising, playing, then you are actually possessing kinetic energy. That means the energy that you have in your body has been transformed into energy in motion, or kinetic energy. And just like energy and then potential energy, kinetic energy has different forms. But again, we will focus on just one, and that is translational kinetic energy. Or we can just simply think of this translational kinetic energy as KE, now the kinetic energy that is usually mentioned. And of course, there's a corresponding formula for kinetic energy that is equal to 1/2 times the mass of the square of the velocity. Okay, in other words, Ke is equal to 1/2 mv squared, where m is the mass as you know it, and v is the velocity. So if you look at the formula, velocity is multiplied to itself, okay, and then multiplied to the mass, and then to get the kinetic energy, we get 1/2 of that. When 1/2 of the product of mass and the square of velocity, then we get kinetic energy. All right? So let's move on. So let's now talk more about the gravitational potential energy, okay, or GPE. So you already know that gravitational potential energy from the term itself, no, gravitational, that means gravity has something to do with this, okay? So the amount of gravitational potential energy that a body has therefore depends on its location or elevation from a reference point and its mass. What does that mean? This just simply means that the higher the object is, the greater would be its gravitational potential energy. Okay, and then to measure how high, there has to be a reference point. Okay, meaning this is where you start to measure the height from. Normally, the reference point is measured from the ground or the floor, but it can be anywhere else as long as you indicate where you will start to measure. But for our purposes, for grade 8, we will be using the ground as our reference point. So take a look at the illustration on the right. So we have here like a wrecking ball that's attached to a machine, right? So the main purpose of this machine is to um, uh, well, I don't want to use the word destroy, but that's basically the purpose, no? It's to get rid of an existing structure, no, very easily by just using that gigantic metal wrecking ball to hit it, and then of course the structure will be destroyed. Okay, so we have these two. We have the first one and the ball at the end of the wire is a metal ball. So we would expect a metal ball to have a larger mass, right? And then, or mas mabigat. And then we have on the other wrecking ball, we have just a plastic ball, a plastic ball. Okay, so if you look at these two, the balls are hung from the same height, starting from the ground. So if this is the ground, right? So let me just draw on that. Okay, so if this is the ground, right? So this would be your reference point, correct? So this is the reference point, no? So this means this is where you will be measuring your height, no? Vertical height. So if we look at, well, let me indicate if this is the center of the sphere of the metal ball, then this would be the height, h, okay? And then the plastic ball would have the same height as the other one, correct? So now let's compare their gravitational potential energy. So if you recall the formula for gravitational potential energy, it's mass times gravity times h, sorry, like h, not 8. And then G is always just equal to 9.8 meters per second. Always, always. We don't change the value. And then well, just by looking at this formula, we would be able to predict that the metal ball would have a greater gravitational potential energy because it has a much greater mass compared to the plastic ball. So what does this mean? So anything that's hanging from a certain height, let's say two objects hanging from a certain height, and they have the same height, if one has a greater mass, then that object will have the greater potential energy. Okay? Because greater gravitational potential energy does not just depend on the height, it also depends on the mass of the object. Okay? But then again, if we change the heights, then that will increase. Let's say let's change the height of the plastic ball, let's make it higher. That will then increase its gravitational potential energy. But will it be greater than the gravitational potential energy of the metal ball? It depends. It depends. So we can actually use the formula in order to answer that question. Okay. So next slide. So let's now look in detail, no, in more detail at the formula for gravitational potential energy. So gravitational potential energy again has the formula mass times G times H, where again G is a constant value, it doesn't change. It's 9.8 meters per second squared. If you look at other books, this value might be different. It might be rounded off to 10, or in high school, we normally use two decimal places. So this will be 9.81 meters per second squared. But for us, we will just be using G equal to 9.8 meters per second squared. All right. So what does this formula mean? This formula just means that the gravitational potential energy is directly proportional to both mass and height. O ayan na naman, this is the term, directly proportional. What does this mean? So again, if you recall our previous lesson, directly proportional means if one quantity is increased, the other quantity also increases. If one quantity is decreased, the other quantity is also decreased. Okay, so what does this mean? When two quantities are directly proportional, that means what happens to one quantity also happens to the other. Okay, So they both increase, they both decrease, etc. All right. So again, the value of G is a constant, and you know that. And again, usually the height is measured from the ground. Okay. And since gravitational potential energy is energy, the unit for GPE is still the joule, or it has the symbol J. And then let me direct your attention to the pyramid here on the right. So apparently you can also use this pyramid for quantities that are more than 3. Okay, what do I mean? Because before, when we use the pyramid, we just solve for the second law, no, right? And then the formula for work. But this time, we are using the pyramid for gravitational potential energy. And of course, you put gravitational potential energy on top of the pyramid. And on the bottom, we put mgh. Okay? So let me just explain this to you really fast. So if we are looking for the gravitational potential energy, that's easy. We just multiply all of the quantities at the bottom, right? So mass times g times height. Okay? But what if we are looking for mass? So what you do then is we divide. Now, what do we divide? Gravitational potential energy divided by G, and then we also divide by H. Okay? So the value of the GPE is divided twice by the uh, gravitational constant 9.8 and by whatever height the object has. Okay? On the other hand, if we're looking for the height itself, so that's just GPE divided by M, then divided by G. So in other words, the gravitational potential energy is divided by the mass, and it's also divided by G. Okay? So if you're ready, let's move on to solving some word problems. All right, so let's take the first one. So let me just move this on top. So sample problem 1. You have a 7-kilogram box which is lifted from the garage floor and is placed on top of a cabinet. Okay, so placed on top of a cabinet, and this is the cabinet in question. If the box gains 150 joules of gravitational potential energy, how high is the shelf? Okay, so let's imagine what's happening here. You have a 7-kilogram box. So this is 7 kilograms. And then you're supposed to lift it on top of a cabinet on the garage floor. So maybe here on top of the cabinet itself. And then if the box, no, the box as you move it gains 150 joules. So 150 joules. The unit is joules. So again, reminding you that the unit gives you an idea of what the quantity is, right? So 150 joules of gravitational potential energy. Then the question is, how high is the shelf? Okay, so now we are asked for this, the height of the shelf. Okay, so let's solve for that. Again, we use the Gauss method. So let's start with the given. So the mass is 7 kilograms. Gravitational potential energy is 150 joules. And of course, even though it's not stated in the problem, it's also good to write the given, the G, not the given value, 9.8 meters per second squared. Okay, so always just write the value of G under the given. And then we look for the unknown, and we know the unknown to be the height, right? So let's now solve. So just go back, no, go back to the formula for height, or let me just show it to you here. So we have the pyramid GPE here on top, and then the bottom we divide by 3 for the mass, G, and height. Okay, so we're looking for height. So that means height will just be equal to the gravitational potential energy divided by the mass and G. Okay, so now we just substitute. So that's 150 joules. We can skip writing the units because they are in their proper units anyway. And then we divide by 7, and then G, 9.8. So when you're using your calculator, this is how you do this. So that is 150 divided by 7, then divide by 9.8 again. Okay, and then you are supposed to get 2.19. I rounded off to two decimal places, and the unit for height is still the meter. Okay, so please practice this using your calculator. See if you will get 2.19 meters as well. All right, so we have answered the question. The height of the shelf is 2.19 meters. So if you need more time to understand the solution to this problem, you can always just pause the video. Okay, so let me now move to sample problem number 2, the second and last sample problem for gravitational potential energy. Okay, so this time, you are supposed to compute for the mass of a man who climbs a wall that is 4 meters high and gains 2,500 joules of gravitational potential energy. Okay, so the problem is very much straightforward and simple. We know right away what that we're supposed to compute for the mass of this man, and then who climbs a wall that is 4 meters high. So that means this is 4 meters is the height, and gains 2,500 joules. So 2,500 joules of gravitational potential energy. So that's energy, and we can also guess that from the unit itself, right? So let's now write the given. So we are supposed to compute for the mass. So the given is the height of the wall, 4 meters, and then the gravitational potential energy is 2,500 joules, right? And then let's just write the constant. G is equal to 9.8 meters per second squared. So take note of the unit of G. This means G is acceleration. No? Specifically, this is acceleration due to gravity. Okay. And then we have the unknown to be M, the mass. So let's now solve and again refer to the pyramid. So let me again write or draw the pyramid in here. So you have GPE on top, and then you divide the bottom into 3 parts, M, G, H. Okay, so we're looking for H. So that means H is equal to GPE, as you can see from the pyramid, divided by mg. Okay. Oops, sorry, we're not looking for the height. Instead, we're looking for the mass. Sorry, my bad. So let me just erase all the formulas. Okay. So we're looking for M, mass. So that's just equal to GPE over these two, GH. Okay, and then just substituting the values, GPE is 2,500 divided by G is just 9.8, and I'm supposed to multiply it the height of 4. Okay, so again, using your calculator, this will just be 2,500 divided by 9.8, then divide again by 4, and you will get 63.78, no, rounded off to two decimal places. And then this is mass, so the unit should be kilogram. Okay, so we have answered the question or the problem already. So the mass of the man who climbs the wall is 63.78 kilograms. Okay, so again, if you need more time, please just pause the video. Okay, so moving on. Let's now talk about some word problems related to kinetic energy this time. Okay. So we have, let's recall the formula for translational kinetic energy, or KE simply. So translational kinetic energy is the energy due to the movement of a body from one point to another. Okay, so translational kinetic energy, it's due to the movement of a body from one point to another. For example, if you run from, let's say, the canteen to your classroom, right? So then you would be transforming the energy that you have in your body into translational kinetic energy. Okay? Or if you move a book on the table from one edge to the other edge, then the book will also possess translational kinetic energy, now due to the change in position from one point to another. Okay? So the kinetic energy that a body has depends on its mass and its velocity, and we can actually see it from the formula, right? So kinetic energy is actually directly proportional to the mass and the velocity. So what does that mean? It means that if we increase either the mass or the velocity or both, then the kinetic energy would also increase. And looking at the formula, please don't forget the 1/2. So whenever you multiply mass and the square of the velocity, get half of that, no, or divide by 2, you will get the kinetic energy. Okay? And again, we can actually use the pyramid to write the formula, or to put the quantities involved in the equation for kinetic energy, so that it would be easier for us to determine the formula if we're looking for either mass or velocity. Okay? So again, just draw the pyramid, kinetic energy on top, divide the bottom by 3, just like for gravitational potential energy, and then just write 1/2, then m, then v squared. Take note, this is v squared, right? Please don't change anything that's in the formula. All right, so I think we are ready to start solving word problems related to translational kinetic energy. Okay, so let's look at this. Sample problem number 3. So we have a 650 kilogram roller coaster car that moves at 19 meters per second. Determine its KE, or kinetic energy. Okay, so looking at what's given, so let me just underline 650 kilograms. So what is 650 kilograms? By looking at the unit, we know that it's the mass of the roller coaster car. Okay, the roller coaster car. So if you look at the illustration, this is the car, the entire car. Okay. And then it moves at 19 meters per second. 19 meters per second. Looking at the unit, meters per second. So this gives us an idea that this value is actually the velocity. Okay, and then we're supposed to look for the kinetic energy. So let me just again write the given. So mass is equal to 650 kilograms. Velocity is equal to 19 meters per second. And well, we actually don't need G because we're talking about kinetic energy. All right, and then the unknown. Unknown would just be the kinetic energy. All right, so this is very much a straightforward word problem. We just use the formula for kinetic energy. So kinetic energy is equal to 1/2 times mass times the square of velocity. You can also write it this way. Kinetic energy is equal to mv squared divided by 2. So these two formulas are exactly the same. Okay, you will get the same answer. All right, so let me use this formula. So that's equal to, the mass is 650, the velocity is 19, and then we're supposed to square it, then divide by 2. Okay, so look, using the calculator, again, we always follow PEMDAS, no? So if you are doing this manually, you're supposed to multiply 19 to itself first, then to 650, then divide by 2. Okay, so let me do that. 19 times 19, or 19 squared, times 650 divided by 2, and I'm supposed to get a very big value, 117,325, and since this is energy, the unit should be joules. Okay, so this is the final kinetic energy, 117,325 joules. If you are solving for kinetic energy and your final answer seems to be a really large number, don't worry. kinetic energy or energy is supposed to have a large value, especially if you have a large mass. Like in the case of the roller coaster, the mass is 650 kilograms, so we expect really a big kinetic energy value at the end. Okay? So again, pause this video if you need more time. You can even practice on your own. Just cover the solution and then try to solve this on your own. And I also encourage you to practice using your calculators. Okay, so moving on to the last sample problem number 4. So in here we have a circus. So in a circus, the 50 kilogram platform diver had a kinetic energy of 10,000 joules just before hitting the water. Compute her speed just before she splashes into the water. Okay, so this is the platform and the diver is known as a platform diver. Okay, and this is a circus, so the diver is supposed to perform stunts. Okay, so as you can see from the image, the diver is actually performing a stunt. No, what's this? Actually rotating before hitting the water. Okay, and then let's look at the given 50 kilograms. This is obviously the mass, kasi kilogram, and then 10,000 joules. This is the kinetic energy. And then we are supposed to compute for her speed, okay, or her velocity. So let's write the given. So the given is just mass equal to 50 kilograms. And then the kinetic energy is just 10,000 joules, right? And then we are supposed to look for the speed v. So let's solve for this. And this time, it would be helpful if we draw the pyramid for kinetic energy. Let me do that for you. So KE on top, divide the bottom into 3. First part is 1/2, and then m, then v squared. So take note, we're looking for v, okay? Not v squared, but v, but let's use the formula for v squared first, and then we will do something to v at the end so that, or to v squared at the end so that we can get just v, okay? So we're looking for v squared. So looking at the formula, this is just kinetic energy divided by 1/2 of the mass. Okay, so in other words, for the denominator, you're supposed to get half of the mass. All right, so let's do that. Kinetic energy is 10,000. Okay, and then we are supposed to get half of the mass, which is 50. Okay, so I think it will be easier for you to solve the denominator first, right? So this would be 10,000, and then 1/2 of 50, that's 50 divided by 2 is just 25. So now it's easier to look for v squared. So just get your calculator. So this is just 10,000 divided by 25. Actually, you can solve for this mentally, and that is 400, right? So v squared is equal to 400. But we're not looking for just v squared. We're looking for v. So if you recall our previous word solving word problems lesson on not circular motion, on centripetal force, diba? So whenever you're using the formula for centripetal force and you're looking for velocity, and the formula also states v squared, you have to do something to v squared at the end so that you will get the value for just v. Okay, so in this case we need to get the square root, right? So we need to get the square root of both sides, right? The square root of v squared is just actually v, which is what we're looking for. And then the square root of 400, you can actually just use your calculator to type in the square root symbol or the radical symbol, then 400, and that is supposed to give you 20, okay? But since 400 is a perfect square, what you can do is just think of a number that when you multiply to itself will give you 400. And that would be 20, kasi 20 times 20 is 400. All right? And then don't forget, Once you have computed for V, the value for V, don't forget to put the unit, which is meters per second. Okay, so now the answer to the question, what's the speed before she splashes into the water? It's just 20 meters per second. Try these problems on your own, and this you can actually find these problems on pages 51 to 52 of your textbook. Okay, so let we have now come to this part. So we're near the end of this lesson. I just want to ask you, what new thing have you learned today? And then here are just the references for this lesson. No, of course, I'm using your textbook, and then just searching Google for images and jiffy.com for GIFs. And of course, I have again just started using the Bitmoji. Okay, so that's it. That's it for today, grade 8. So once again, good morning, and I will see you on Friday. Bye bye. Stay safe and God bless.